Hello everyone, welcome to my channel. So today we are going to do Leetcode daily challenge, integer to Roman. So here as the question name says that we are required to start from integer value which is being given to us, and then after that we are required to convert that integer value into Roman numbers. So that's the thing which we are required to do. So first we will read this question, then about the constraint, and then we will be going ahead with the intuition behind this particular question. So that's the thing which we are going to do. So now let us first read this question. So we are Roman numerals are represented by 7 different symbols, which are these, and the value corresponding to that is given here. Now, for example, 2 is written as this in Roman numeral, just two ones added together. So basically, it's all about that how Roman numerals have formed. So that all we already know because we have learned about all these things in our elementary classes, like in first, second, third standard. There we learned about that how integers are being from Roman numerals. So that's all description is given here. So our main part is that given an integer, convert it into Roman numeral. So here 3 is given to us. So we will be directly writing this. 58 is given to us. So this is 50. Sorry, this is 50. And then this is that 80, that 8 which is being given to us. So all these things are like this, and we will be given with Roman numeral at max till 3999. So basically, not even 4000 would be given to us because if 4000 would have been given to us, then we would have considered that 1000 means that 5000 minus 1000 Roman uh, character as well. So that's the thing that we are given with this much only. So now let me explain you that how we can go ahead for this particular solution. So let us take this example, and from this example I'll let you know that how we can devise solution for the same. So now let us start. So here see, uh, we are given with this number. Say we are given with this number. Okay. So 2322, right? So how we can divide in the sense means how we can break down this particular number. So basically, this whole number could be break down to 2 multiplied by 1000. I'm breaking this down as per this thing. Means 1, then not x, but after that there are some more digit which is there. So 1 after that we have 4, then we have 5, right? Then after 5 we are having that what we say that 9. And for 9 because it is 1 minus that x and then x. Then after that x we are given with xl, that is 40. Then L, that is 50. Then after that we are having that 100, right? So 100 is I guess C, and we do this for giving us 90 and then C, that is 100. Then comes the part for that uh, D, yes. And for D, we directly do CD for 400 and then D is there. Then comes the 1000, and before that 1000 we are having this 1000 is M, right? And we do 100 and then we are having this, right? So basically, how we are going to partition our number which is being there as per these Roman numerals. We will be basically mapping our Roman numerals to the values which are being given as input here. Values here refer to the integer values which is so we will be means because of those things only. So we are splitting our integer which is being given to us in that manner only. So first thing is we will be required to check that from these Roman numerals which are given to us. So which is that highest Roman numeral from which we are required to partition are this particular given number. So that's the thing which we are required to do. So what we will be doing is we will be checking that we will be starting from the last index. because see, we are first required to check for the highest Roman numeral which we are required to select, right? So we will be starting from last number and then we will be comparing this particular integer which is being given to us, that are we able to match this particular with that particular Roman numeral or not. If we are able to, then we will be directly checking for the count which is being there, and this would be that count. Basically, because of this count only, we will be able to get our that particular portion of Roman numeral. So what I'm trying to say is that we will be checking that what is that highest Roman numeral corresponding to which we can get our first value which is being given to us in this particular input, and then after that, that what is that, because you already know that 1 is being written as this, right? 2 is being written as 2 multiply by this, right? So because of this fact only, we are required with some count value also, and because of that count value, we will be easily able to do that thing. And thus, we will be first when we are able to get this, right? So at the next step, we will be checking for the next values which are being left there. So whatever we got at this particular portion, we will be subtracting that from this, and then we will be getting this particular, and then we will be checking for the same, that how we are required to get the other thing which we will be now heading over to. So now same thing would be done for this particular thing also. And after that, we will be going to do same thing for this other thing also, that is 322. So for in this 322, what we are required to do is, again we will be checking that highest Roman numeral which map to this particular. So the highest Roman numeral which maps to this particular 3 is basically 100, right? So our index would be at this particular point, and after that we will be just directly checking for that what is that particular count with whom we will be multiplying and getting at this particular 300. So that is 3, right? So that's why we will be first we appended that m2 times, now we will be appending 3 times 3. So that is till now we got our Roman numeral, and then we will be subtracting whatever we did till now from this particular, so that we can get our final means our next number, that is 22. So for this 22, again we check that what is that highest Roman numeral corresponding to which we can map our this particular integer, so that we got as the 10, right? So that's why then we got the count, and after multiplying that with the count, now we will be appending that to the answer, right? And now comes the next part, that is our last which is being left, that is 2. So for this 2, what we are going to do is, now we'll again check that what is that highest number, that is this particular I, right? So we'll multiply by 2, and then at the end, this is how we will be getting our answer. Basically, this was straightforward for this part. That means whatever the highest value which was there corresponding to that integer. So that what we were getting at that particular. But now comes the part when there are some numbers like 4, 6, and 9. Then at that moment, what we are required to do. So for that purpose only, I have taken the second example, and let me explain you that example as well. So in the second example, it is not scrolling up. Okay. Yeah. So in the second example, we are given with 3469, right? So in this 3469, the highest number which maps to this particular 3 is 1000, right? Then we are multiplying by 3 so that we get 3 times m, right? Now after that, whatever we got, now we will be subtracting that from our this particular number, right? So after subtracting that, now we got this particular 469, right? So now what is that higher number which correspond to this 4? So that is 400, right? And that count would be 1. So that's why we are directly appending it here. Now comes the part for 69. For 69, the highest number which correspond to this value is 50, right? So we are appending that 50 here. And then comes the part for 19. Means from 69 it becomes 19. And now we will be checking for that 10. And then we appended that 10. And then at the end remains the 9. And then the count becomes 1. And then we are appending that 9. So basically, this was for our second example. In both the examples, only difference is this thing only. That because of that 4 and 60, we are doing those count also in different manner. And according to that only, we will be required to create a basically hash map in which we will be keeping those particular Roman numerals. So that's the thing which we are required to do. So that's why I took these two examples. Means first is just straightforward where the count is basically greater than 1 as you can see, right? But in this second one, here some counts are equals to 1 only, and sometimes we are required to take this particular scenario also. From 69 it became 19, right? So that's why I took this particular example. So now just either do dry run on some more examples by your own, and then you will be easily able to devise this particular solution by your own. So that's the beauty of this particular question, that it is a straightforward question, but for that purpose you are required to check that how from a particular Roman numeral map you are required to get your values. So that's the thing in this particular question. Now let us start with the algorithm, that how we are required to do this particular. So the thing is that first whatever number is being given to us, so from that number we will be checking that what is that highest number to which this particular integral value maps to. And after that we will be checking that particular Roman numeral, right? So corresponding to that number we will be dividing that number with the present number so that we get the exact count. Because see, because our Roman numeral will be corresponding to this 100, right? Corresponding to this 1000, right? So when we divide this 322 with this particular 1000, okay, then we will be getting 3, right? And because of we will be getting this 3, right? So that's why I was saying is we will be dividing the same so that we get the count. And after getting that count, we will be directly subtracting this 3000 so that we can get this triple two, which we are getting at this next step. I just changed the some digits, so just let it be, right? And after that, we will be checking for this particular, that what is that highest Roman numeral corresponding to which we are able to get it. So we got that 2, right? And because of that only now we will be subtracting it, and now we will be getting 22. And then how we get this 22? So that is by 10, right? So we will be subtracting this 20 so that we get this particular 2, and 2 is straightforward by 1, means 2 multiplied by 1, and that will be our final step in the same. So like this we are required to devise this particular solution. So now let us head over towards the coding part for the same. Yeah. So for coding part of the same, let me show you direct code, means I won't be coding today. So here the first thing is that we are required with this particular vector. Oh, this is much better. So we are required with this values of vector. So how values we are taking is, we are taking for one, that is the uh, standard thing which is given to me, standard Roman numerals, that is 1, 5, x, then L, then C, then D, and then M. These are the standard which are being given to us, and then we are also required to have the that 1 minus or 10 minus or 50 minus or 100 minus 1 also. So basically that's why we are taking this IVIX, right? XL, and then XC is also we are taking, and then CD we are also taking, and CM we are also taking. So that's the thing which we are doing here. And corresponding to that only we are taking another vector where we are storing these values. So now let us start with that how I had explained you so that we are required to code the same. So while a number remains greater than 0, because this is that case because we are also subtracting the same, right? So because of our subtraction only, it will reach to 0 also, right? So we are taking this that while a number is greater than 0, so till then first we are going to check that what is that highest number till that we are able to get at this particular num. So that's why we are doing like this, means our num until it is less than our value of index. So we are subtracting our index so that we can get to that particular position, that highest position at which means after which we can get our count basically. So here we will be getting our count. So that is for that 3000, we will be getting 3 multiplied by 1000, right? So we will be getting count as 3. So here multiplying 3 with our that particular value that is 1000, and we will be subtracting that from num so that we can get our 3 triple two into triple two. And then here's the part for appending our answer. So we had got that count value, right? So that because of that only, and even we were having that index also, right? So because of that, whatever corresponding Roman value would be there to this particular index, that we will be appending to our answer. So that's what we are doing. And then we will be again means after this, because our number is still greater than 0, then we will be checking again that what is that highest number and then count and then subtracting that from the num, and then we will decreasing our count and appending the answer, and this whole process will be repeating until our num becomes equal to 0. So then at the end we will be returning our answer. So this was all for this particular question. Now comes the part about um, the time complexity. So basically the time complexity here is this is num, so order of n, right? And now comes the part because we are dividing here, right? That's why our num is basically decreasing. So not order of n, because of this division part only, we are basically dividing it. It is somehow like the way there is that tree, right? So in tree also, we all know that a particular binary tree which is being there, it is always divided, right? So that's why our height becomes log of n, right? So because of that manner only, we are as dividing corresponding to a value of I. So at each step at 2, 3, 3, right? So it becomes now 3, 3, then it becomes 3, 3, and then it becomes 3. Oh, sorry. But I can't do up and down, right? So, right? The way means from 2, 3, 3, it becomes 3, 3, and then it becomes 3, and then it becomes 3, right? So it is somehow like a inverted binary tree only, right? So that's why its height is somehow log n. So because of that purpose only, this particular is log of n. Now comes the next part that there is one more while loop here, and there is one more while loop here, right? So because of this only, we are able to get our means this could run up till total of this n time as well, right? Means say we are having some number, uh, there is 1000, right? So we are having this 1001. So because of this only, this particular will run up till this time, right? And because of that division only, we are able to get that log n. But now comes the part of this loop and this loop, because of that count and because of this index, we are able to accumulate them and it will get up till this n. So that's why we are getting this particular time complexity as n log n. And about the space complexity, so that is constant because we are having this much what we say it as this much constant numerals only and constant in what means integer value and the string value, this much is there. So that's why the space complexity becomes order of 1, but the time complexity becomes order of n log n. So that's how the space complexity and time complexity is there for this particular. And yeah, this was all for this particular question. If you have any doubt, you can comment that down. And if you like the explanation, please do like and subscribe to my channel. So this was all. Thank you.